heard this story throughout the conference. It's evolving across the board. It's not a space to despair. Here you see a chart from Deloitte that shows you all the areas of banking that are being disrupted and innovated. You don't have to read the fine print, only to understand that it's everywhere. And banks are changing from super apps. It's not just open banking, it's not just APIs, it's blockchain, it's big data, it's AI. Everything is changing. There are three main pressures that are driving these changes: rising customer expectations, competition from fintechs, and the regulatory environment all over the globe. So what are banks to do? What is this all about? This is really about innovation. This is about banks trying to act more like technology companies. If banks want to act more like technology companies, they're going to have to learn a few new tricks. They're going to have to learn not just about APIs, but about Agile, DevOps, and cloud as well. But of course, the subject that we all know and love, APIs. Maybe you've heard of them. Just about every deck here has a slide that looks something like this. It shows a closed bank turning into an open bank. And the way that it does that is by identifying small pieces of capability, these small chunks, that it exposes as APIs so they can be shared and reused. You might share and reuse these pieces internally, but you also might do it externally, which is going to be called open banking. We all know this story. The thing is, open banking means different things to different people in different regions. You've seen a lot of slides that look like this as well, to show you the mapping of different regions across different concerns, and many of them use the same kind of division that I've used here, a contrast between market-driven approaches and regulatory-driven approaches. In this chart from A.T. Kearney, you see two different axes. You see the regulatory push and the market pull, the implication being that in regulatory environments, you are pushed, you are forced into implementing these innovative technologies, and in the market-based approach, you are pulled into it by competition. Canada is an interesting case. We're sort of on the fence because we have a dual identity. We have a dual identity in a couple of ways. One way, our banking system is very much a mirror of the UK banking system. So from a regulatory and structural perspective, we look a lot like the UK. The thing is, most of our trade and expansion is with the US. So we're sort of stuck between these two worlds. Are we more like our UK, the ex-colony, or are we more like the Americans? There's another dual identity. One of the earlier speakers talked about Canadian caution. That's absolutely true. Our banking system is famously cautious, almost proudly so, especially after the 2008 financial crisis. But we're also incredibly innovative. Often Canada, and specifically the Southern Ontario region where I'm from, is sometimes called Silicon Valley North. We're famous app developers. Google and Microsoft recently announced headquarters in Toronto, where I'm from. I think we're on the short list for Amazon. So on the one hand, we're very cautious in the banking sector. On the other hand, we're very innovative on the technology front. So again, we're caught between these two worlds, and I tell you from personal knowledge that we're still trying to decide which approach to emphasize. I've been talking to some of you here about your opinions on taking the right approach. The interesting thing to know is that from a goals perspective, both of those approaches are after the same thing, the fundamental goals of open banking: competition, innovation, and transparency. They're both trying to get to the same place. But I'm not here to talk about the efficacy of the market-driven approach versus the regulatory-driven approach. I'm here to talk about architecture. So what I really want to focus on is how these two different approaches influence the solution architectures that the different banks implement. So, at first glance, the regulatory approach seems very attractive. Philosophically, it seems just right. You're focusing on opening up data, leveling the playing field, increasing competition, giving consumers protection of their data. As a technologist, I'm a technologist at heart, that really warms my heart. This is how the internet should have been from the beginning. I think this is wonderful. But there's a problem. There's nothing about the regulations that say you have to modernize your backend. All the regulations say is expose APIs. So what happens is, because you're on a forced march towards adopting these new technologies, you take all your IT resources and focus them on publishing open APIs, because you've got a date to hit. If you don't hit that date, you're going to get fined. No IT resources then are working on modernizing how you code, package, and deliver software faster. So that's going to slow you down. You're going to build up these developer communities. Developers are going to start using your APIs. The second they start asking for changes, you're going to find that encumbered by your old legacy systems, you're not going to be able to move very fast. Your developers are going to get upset. By contrast, the market-driven approach is unencumbered by regulation. What that means is they can focus on code, package, and delivery, and take the best lessons from the tech companies that show them how to do that in a modern way. So while the regulatory-driven solutions are focused on open APIs, open data, developer experience, common standards, under the surface, all of those market-driven solutions are focusing on agile requirements definition, consumer-driven contracts, precise scaling, distributed data using events, big data lakes, automated deployment using DevOps, private cloud native solutions, all of which can sort of be put under the banner of continuous improvement, continuous delivery, CI/CD. In a nutshell, the regulation-driven solutions focus on API management and control, whereas the market-driven solutions focus on delivery speed. The thing is, to have a comprehensive open banking solution, you need both. It's a good button. So let's take a closer look at the architecture and how it manifests itself in these two approaches, with a particular focus on the role of the API gateway, a big part of probably a lot of your solutions. The thing is, most vendors out there will position their solution in a very particular way. They'll say, we've got you covered. Buy our solution, put it between your legacy systems and the APIs, and we will do everything for you. If you've worked in IT a long time, then you've seen this before. It goes by different names. If you go back far enough, it used to be called ERP, then it was called EAI, then it was called SOA, done poorly, it could be done properly as well. And the most recent label given to this approach is API management. I have a different name for it. I like to call it the magical black box. Give me all your systems, hook them into this amazing hub, and it's just going to solve all your problems for you. Now, to understand this a little better, you have to understand what a gateway actually does. A gateway takes care of what are known as cross-cutting concerns. Typically, these involve consistent routing, security, monitoring, and logging. What these vendors will say is, I'm going to add a bunch more onto that. You're going to get transformation, workflows, visual, toys, and stuff like that. And again, we're going to solve all your problems. This kind of solution, this magical black box solution, can be very attractive to folks who are driven by regulation, forced march, trying to become compliant. Someone comes in like a MuleSoft or a CA and they say, don't worry about it, magical black box, I promise I'll get you to market in time, you won't pay any fines. Don't worry about the legacy. Magical black box will take care of everything. Practically though, even if you managed to implement this thing successfully, good job, because sometimes they can be quite unwieldy and proprietary, you're very quickly going to find yourself in a bit of a bind, because these types of solutions don't scale. They act as a developer constraint, because they often have very proprietary mechanisms, and operationally, they act as a single point of failure. That's why when you look at the GAFAs, they wouldn't touch these things with a 10-foot pole. So what do they do? What do mature organizations do? They take a different approach to solving the gateway problem. They take a distributed gateway approach. What is the distributed gateway? What that means is, instead of having a central hub, a magical black box, you push all those cross-cutting concerns to where they belong, to the endpoints. What you're essentially doing is embedding a tiny gateway into each individual microservice. Now, to understand that, you have to understand a little bit about what a microservice is. So, microservices. Microservices and APIs are not the same thing. Those terms are often conflated. It's worth understanding what people really mean when they say microservice, because it really is the secret sauce to delivery speed. APIs are just the contract. Microservices are the implementation. Microservice is not a small API. It's not an API that does just one single function. It refers to the code, how you actually implement the code. APIs are just a contract. They're just the agreement that says, if you send me this data, this is the data I'm going to send you back. The best way to illustrate this is by example. Let's say you have a mainframe, 50-year-old mainframe, it does 10 different functions. And you really have to get to compliance, and you want to publish modern APIs that are open and everything on top of this mainframe. Magical black box will do it. A number of technologies will do it. You can take the most beautiful, wonderful JSON, REST, even GraphQL, gRPC APIs, the most modern APIs you've ever designed, and implement them on top of that mainframe, because APIs are just a contract. There's no code in an API, it's just an agreement. The thing is, let's say function number 10 that you expose by an API starts to get really popular, really important. Lots of developers start hitting it. They start asking for changes. They say, can you give me one more field or two more fields? Or let's say it's really popular for a different reason. It's Black Friday and you really need that API to be able to power some sort of deals, and the volume goes up to 1,000 times what it normally is. What are you going to do? Change the mainframe. I'll see you in 6 months, if you're lucky. Then you go back to the developers and you have the same problem. They're upset. You gave me these amazing open APIs, you promised me a wonderful developer experience, I asked for a change and you can't do it for 6 months? I'm going on to Twitter to talk about how terrible this bank is and how they don't understand open banking at all. So what do microservices do? How do they solve that problem? Microservices offer you a way to decompose those old monolithic applications. And the way they do it is by strangling off the pattern, it's actually called the strangler pattern, these individual functions, and repackaging them into tiny applications that are completely self-contained. You may have heard the term Docker. You may have heard the term container. Well, that's what this stuff refers to. It refers to getting rid of your old J2EE application servers and replacing them with containers, typically based on Docker, which is the current leader. So you take your old mainframe, you re-implement all 10 functions into tiny microservices, and then publish APIs on those tiny microservices, and you have a fundamentally different architecture. You have an architecture where your monolith is replaced by a collection of microservices communicating with each other via APIs. Why would you want to do this? Because each of these pieces is now independently upgradable, precisely scalable, and completely portable. Independently upgradable in the sense that you can change just a single function without touching the other 9. Precisely scalable because they run in a cloud environment or a container environment that can automatically create or destroy as many instances as it needs to deal with the load. I'll talk about that a little more later. And they're completely portable because that tiny application that you've packaged into a container runs the same way anywhere. It runs the same way on your laptop as it runs in your production environment at your bank, and the same way as it runs in any public cloud provider. They call that immutable. So this is really the secret to delivery speed. And without it, you're constantly going to be shackled by your old legacy mainframes and your tech debt. So to sum up, APIs may make design easier. You will genuinely gain a benefit from publishing your APIs on the consumer side. They will find it much easier to consume the APIs, to start using them practically, but you won't be able to deliver changes to the back end any faster. That's where microservices come in, offering the answer to do so. They're the only way to get to this holy grail of high-speed release cycles. The thing is, microservices themselves are evolving pretty rapidly. So we started off in this monolithic world, and that's where most of the API gateways that are out there today live. Most of the API platforms that are out there live. They're monolithic. They don't really fit with public cloud platforms. And that's why none of the big guys really adopted that approach. They moved immediately to microservices. The thing is, even in the microservices world, where you decompose your monoliths and created these tiny applications, you still have to deal with those cross-plane inserts that I mentioned earlier. So the way that the GAFAs and other fintechs dealt with this problem is by incorporating standard client libraries. You release libraries that they would package inside of each microservice. The most popular one out there for doing that kind of approach is Spring Boot. And what that would allow you to do is sort of have your cake and eat it too. You've got true microservices, which means you're fully distributed, but you still have control because you've got these standardized libraries running in each of your microservices. This pattern came to be called microservice chassis pattern. But at some point, those libraries got too difficult to manage. There's too many different versions. They couldn't keep their developers aligned. Remember, these are the big boys. These are the Googles and Amazons of the world who couldn't keep their developers aligned around these libraries. So even they ensured how they were approaching cross-plane inserts in the microservices world and introduced a new pattern called the service mesh. Now, service mesh is so new that we're still wiping the muck off the baby. Istio, which is the leading service mesh implementation from Google, just went 1.0 on August 2nd of this year. So service mesh is ultra new. But it's a big step. What they did with service mesh is pulled all those libraries out and put alongside each microservice a dedicated proxy, a dedicated sidecar. So now your microservices themselves don't even have to worry about the cross-cutting concerns. They don't have to worry about embedding a library. They have a dedicated sidecar that's going to create an abstraction layer for each individual microservice. So now you've abstracted control of your cross-cutting concerns even further. New entrants in the API's platform space, they don't go gateway at all. They go straight to at least service mesh, if not completely serverless. We've watched over the course of the last year and a half or so as all of the incumbent vendors in the API platform space have radically tried to repackage and transform their solutions to fit more with the architectures on the right. IBM has repackaged their strong loop offering as a micro gateway. CA Layer 7 has repackaged their offering as a micro gateway. Com, who you might recognize that icon from that little gorilla, their CTO is one of the biggest proponents of service mesh, even though their platform has a pedigree of being monolithic. So the industry's moving. Right? Monolithic API gateways are a thing of the past already. Now, if that doesn't worry you, what should really worry you is even service mesh is not the end of this evolution. Tech companies are already looking beyond service mesh to full serverless, where you're essentially deploying raw source code right into public cloud providers. That is so early that it's not even worth exploring for banks like us. I saw a couple of reactions from the audience. Maybe it is, but it's very almost experimental. The thing is, when you go to tech conferences, which is where I usually present, everyone there's focused on the far right of this diagram. They don't even have these conversations. But most banks, not only are they stuck with monolithic legacy, they're now stuck with monolithic API platforms. What I'm trying to tell you is the volatility is not going away. It's going to get worse. Right? This target is moving. It's not something that is fixed. And if your current architecture is based on one of these monolithic platforms, I promise you, it will quickly become tech debt, and you will be forced to re-platform sometime over the course of the next 5 years. Moreover, early adopters who understand this transition and move towards service mesh and serverless are going to gain a significant lead over their competitors. Let me be clear, that lead is a delivery speed lead. I talked earlier about creating the right developer experience. It's not just about having nice APIs and a nice portal. It's about being responsive to the developer community. To do that, you need an architecture that can change easily and allow you to deliver quickly. So, you might think, well, this is nuts, right? This is theory. Different proxies. It's not affecting the performance at all. It's pushing things out. Nothing ever travels up to the control plane. It also acts as a common place to track all the logs and monitors. But again, all of this communication with the control plane is done asynchronously, so it's incredibly scalable. The tech you will often hear associated with this is Kafka, but you can use any kind of messaging technology. The red boxes are indications of domains. Those domains are defined by typically domain-driven design, if you did it properly, and what they essentially are groupings of business capabilities. The intention is that they're completely fluid. If you wanted to change your domain boundaries and move them around, that should be a very easy thing to do. And again, the focus here is accommodating high-speed changes. You may notice there a perimeter gateway. The perimeter gateway is still there as an edge service to create customized experiences for developers, but it does very little. The typical technology you use in this architecture is Nginx. It acts as an ingress-egress point to get on and off your network, but it does nothing else. It's not fat, it's incredibly thin, and even there you're probably running lots and lots and lots of them in parallel, trying to distribute the load as much as possible. It's essentially a control point, but it does very, very little. It's only there to demark your network from the outside. So you have these lightweight proxies. You have the microservices that allow you to update individual functions on their own. You organize them by domain, you distribute your policies using a control plane, and you expose them to the outside world via a very skinny perimeter gateway. That is essentially the service mesh architecture. Now, the reason the service mesh architecture is so great for open banking is you get to have your cake and eat it too. You have precise control of APIs, API management, all the policies that are enforced for all of your individual microservices, and you have the ability to support high-speed delivery. So this is the part where I say, isn't this just theory? Well, it isn't. We actually did this at CIBC. Sorry, guys. So, what was it like to build a service mesh for a bank? How did we get there? When we started our journey, we did what I'm sure a lot of you did, folks did. We went out and looked at the leading vendors, drove their solutions, put them up in test environments and so on. But we very quickly realized that not only was this not compatible with our microservice delivery aspirations, it wasn't compatible with public cloud. So on the input of my boss, the SVP of Enterprise Architecture, he said, narrow the playing field to cloud native, open source. Surely looking at that narrow range is going to find you the right solution. So we did. We still found a huge amount of volatility. There wasn't any leading solutions. And if you did find a leading solution, it would be gone in 6 months. So what do? Well, we took a slightly different approach. We found an open source core that we thought was built the right way. We brought the lead developer from that open source project in-house, put a team around him in a sort of incubator fashion, and developed an in-house platform on this open source core. Then, because we weren't going to just be content to take the developer's word for it, they built the right thing, we gave it to a whole bunch of consultants and vendors and said, beat this thing up for us. And they all came back with uniform opinions. Why on earth are you doing this? The documentation's terrible, but this piece of kit that you built is pretty great. It does what you say it does. You build a microservice platform that's fully distributed. It allows services to be independently scaled, independently managed, and you've solved the single point of failure problem. No need for a gateway. Then, because we thought they might be trying to sell us something, we gave it to our friends Nordic APIs in Europe who had never heard of CIBC, so we knew they would give us an impartial view, and they liked it. They even wrote a white paper about it on their blog. So we felt pretty good about this piece of kit we built, but really there were 3 main reasons why we took this build posture beyond whether we were going to build a good solution or a bad solution. One, it was a hedge against an incredibly volatile market. You could not find a leader. I personally sat down with a ton of analysts. None of them could give me a firm answer on who are the top 3. Second, you can steer the technology to suit the needs. So in our case, take GraphQL, which is an advanced API protocol. There's no commercial support for GraphQL from any API platform vendor today. We needed support for it, so we went to our development team and said, build us a GraphQL adapter, and they did, and now we support GraphQL. And the third, probably the most important, is to develop critical internal skills. By building this platform in-house, we're learning about microservices, API design, DevOps, deployment to public cloud environments. All of these skills are portable. They're not going anywhere. Even if in 5 years, one of these useful service mesh vendors becomes the commercial leader and we end up switching to Google's Istio, well, that's fine. All of those skills that we learned along the way are still applicable, they're still portable, and they're skills that banks are going to have to learn. There's no way of getting around having to learn how to create Docker-based images and deploy them to public clouds. That is capital. The train has left the station. So developing these critical internal skills was a major benefit of the approach that we took. So in the end, what did we end up with from this posture? An award-winning API platform that is the world's first service mesh built specifically for banks. So how's this journey going? Oh, sure, now it's so we've taken a lot of great strides towards achieving our goals. The API Foundation is being used across delivery teams. We have an API Governance Council in place with APIs mandated, full managed container environment, CAS, running on OpenShift, which is a Kubernetes variant. Ongoing developer training for microservices. This is critical if you don't have internal training programs on how to build this stuff, then I highly recommend that you do. We have over 200 internal developers trained on how to build microservices using our platform. And finally, we're piloting an internal API marketplace, which is available today, where developers can go publish APIs that are automatically generated into microservices running in our CAS. Already, even with these early releases, we've only deployed a handful of APIs into production today, but we're seeing a significant savings of 50 to 70% per integration. And that's really largely from automation. Right? When you package things as Docker containers, that really lets you take advantage of all of the automation that DevOps tooling gives you and removes a lot of the bottlenecks that exist monolithic deployment cycles. So that's where that savings comes from. That's both a cost and a time savings. Now, I mentioned in the previous slide that this was award-winning. Is that really true? Yes, it is. We were recognized by Nordic APIs earlier this year in Austin as a leader in microservices architecture in the back of this platform. And more recently, we received an award from Forrester and InfoWorld for our EA excellence with a specific reference towards the platform as being a major reason for that happening. So we're very excited about the progress we made. We really think we have a lead on our competitors architecturally. We really think we're setting the pace for where all the other banks in the world are going architecturally. But while we've made some progress towards this vision, we still have a long way to go. So where are we going? Well, we're going to the bank of the future. Now remember what I said earlier. Open banking only regulates the API strategy and platform. It doesn't tell you to do anything else. It just says, at the top of the house, that's what you have to fix. But as I've said, if you don't do those 4 pillars, you're not going to be successful in open banking. It's just that simple. Moreover, if any one of those pillars lags, then it's going to drag the other 3 down with it, because you can't really do any of them without having all 4 in place. So that makes the challenge even harder. You have to go through something like a digital transformation. And if that wasn't enough, if it wasn't enough to have to reinvent how you think of technology and operations, you also have to revisit how your organization is structured and how you culturally think of APIs and openness in general. So the pillars, so the API strategy and platform, that gives you the API management, the API control, the ability to be compliant. The pillars give you the speed, but it's really that culture of openness that you need as a foundation to drive true innovation. So how do you create that kind of technology culture? The most important thing to understand is that the metaphors for IT systems are changing. They're changing from what used to be industrial metaphors, fixed, hard things that never change, and you have to get the design correct up front or the bridge is going to collapse, to biological metaphors, things that are ever changing, things that are constantly in flux. The reason is because there's an acceptance that the systems are ever changing. This quote from Martin Fowler, sort of the godfather of microservices, captures it best. There's no design at the beginning. You begin by coding a small amount of functionality, adding more functionality, and letting the design shift and shape. Just like a biological system, your systems evolve. The great thing about systems that evolve is that they never have to be replaced. You just fix the parts that are broken. You can update each individual function on its own without touching the rest of the system. Think about that. Systems that never have to be replaced. That is the power of an evolvable architecture. And having this kind of architecture in place is critical to the successful delivery of open banking, because at the end of the day, what we're trying to do well, this is infuriating. What we're trying to do is address customer needs. Customer needs are ever changing. Right? That's what open banking is really all about. It's about changing the customer relationship. Historically, customer relationship in the bank has been one based on complexity, uncertainty, and frustration. It's been based on extraction of fees, complex opaque products, and let's be honest, sometimes it leads customers to just outright hate their banks. It's my belief that the heart of open banking is the opportunity to change this dynamic, to get customers to really love their banks. And that's about creating a relationship based on simplicity, transparency, and delight. Ann Bowden, CEO of Starling, said it best: innovation in an open banking context. It's all about addressing real issues customers have and delivering something they really want. One of the earlier speakers used the word authentic. I love that word. I think open banking is all about creating authentic relationships with customers. And not only will that help the customers, but that will create opportunities for all of us. Thank you.
Thank you so much, Eyal. Let's open up for questions, if that's okay. I think I have 3 questions. So what was the timeline for implementation of this API foundation? How long did it take you to build it?
Sure. We've been on the API Foundation journey for about 18 months now. We started off as an internal incubator, where, as I said, we brought in that open source lead. We put a bit of a team around and sort of sequestered them into a room. One of the major challenges we faced was how to get them out of that room and make this status quo for the bank. So we achieved that approximately January of this year, and throughout the year we've been training developers, putting in a proper production environment, run books, controls, etc.
And in terms of training, did you have to train the business side of business change? How does that come together? Because it's a new ecosystem and a new scheme.
Sure. So that's an excellent question. And the short answer is no, because we just sort of ignored them, right? If you understand this philosophy of microservices and the ability to create evolvable systems that are constantly changing, the whole point is that no matter what the business comes up with, it will be very easy for you to address. So it's a very bottom-up approach that focuses most emphatically on developer productivity. Right? The thinking of this movement is, if developers